Today we're going to be doing a demonstration of the MPA II-D. The MPA II-D is the only dairy system on the market that can do both liquid analysis and solid analysis on the same platform. And Bruker's FT&IR technologies is what allows this, and it has several other advantages as well. So on the left side of the instrument we have the LSM, and I'm going to lift the lid up here. And on the LSM we have a pipette with sample indicator, and it's adjustable to allow you to use larger sample vessels if needed. And the purpose of the LSM is to pump and to temperature stabilize the sample prior to analysis. So there are two different pumps on the LSM. One is the peristaltic pump, and the peristaltic pump is used for all samples that are already homogenized. That could be a homogenized skim milk, a raw whey sample, all the way up to a liquid WPC 80 or an ice cream premix sample. We also have a homogenizing pump, and the homogenizing pump is going to use for any non-homogenized samples, and that's going to be a raw milk or a cheese or vat milk sample, so anything that needs to be homogenized. And the reason we do that is that if we're able to reduce the amount of samples we run through the homogenizer, we can reduce the wear on the homogenizing system, and then that's going to reduce some of the service cost of the system. So what the pumps are going to do, either of them, they're going to run sample from the pipette through a rotary valve. The rotary valve is specifically designed for high solids types of products. So from the rotary valve to a heating block where that's going to temperature stabilize that sample some. And then from the heating block, it's going to pump it to the flow cell. And the flow cell that we use is a quartz 1000 micron or 1 millimeter flow cell. So because we're using near-infrared technology, we're able to use a quartz flow cell. And the advantage of the quartz flow cell is that it will not wear over time. So especially if you're pumping high solid samples, if you're using a conventional mid-infrared liquid dairy analyzer, those are going to use calcium fluoride flow cells, and that calcium fluoride will wear over time. With a near-infrared system in the quartz, we don't see that same wear. And if you don't have a wear on your flow cell, there's no need to bias your calibrations or eventually change the flow cell over time. So we're able to run that, not bias the calibrations, and not regularly change out this flow cell. The other advantage is the large path length, and that's because of near-infrared technology as well. When we're using the large path length, that is 1000 microns is 20 times what a mid-infrared system would use. We're able to pump higher solids system samples, so such as a liquid WPC 80 or a heavy whipping cream or ice cream premix samples that have potentially high solids and high lactose levels. Those are things that can plug up a conventional system where we're able to pump those through readily with the near-infrared system. And so that just slides down in, and it's all covered by our cover here. So if we're going to run a sample on the liquid side, we'll just take our sample, and I'm just going to gently agitate it. And this is just to mix in any fat that might have separated out. We don't want to shake it vigorously. We don't want to agitate and incorporate any type of air. So we'll just gently shake it and introduce it to the LSM. So now that this sample is here and we move over to the software, we can see that yes, there's a sample present here, and we can select the product. So I'm going to run this as a raw milk product. So I'll select the raw milk, and I'm going to click Measure Sample. At that time, it's going to ask me what do I want to name the product, so I'm just going to call it Whole, and I'm going to click Measure. So at this point, it's going to do a pre-pump, and then we can hear the homogenizing valve, homogenizing pump start to run. And it's pre-pumping that sample into the heating block. So this is set up to do a 23 milliliter pre-pump. It will delay a couple seconds to warm that sample a little bit, and then pump the sample. And now it's pumped that sample. It's going to wait until it's done scanning. So it's going to do 32 scans, and that's going to take a few seconds. This current product is set up to run triplicate analysis. You can set it up to do single analysis, duplicate, triplicate, whatever you'd like. It's good to see some amount of duplicate because then you're able to see how much the sample analysis is varying, and that can give you some indication of, is there any wear on the homogenizing system? Is it cleaning efficiently? Is there something wrong with the sample? So having that, those duplicates or replicates allow you to kind of get an indication of how well the instrument is actually performing. So now we're on that triplicate or third replicate. It's going to finish scanning here in a couple seconds. And so now we're finished scanning. So when it finishes, it's going to show us all of our replicates down at the bottom, and we can look at the statistics and we can see your percent CV, your standard deviation, to really see how well that instrument's performing. So then, okay, we've run our liquid sample. I'm going to pull this sample out. Now let's talk about solids analysis. So the solids analysis is done on the right side of the instrument. Here we have a rotator, and I'm just going to pull that off just to show you. But this is a rotator. It holds either a petri dish or a sample cup. And the purpose of this is just to rotate the sample so we're presenting all of the sample to the window of the instrument, which is right here. So to reinstall that, put it back on, tighten it down. So a cheese sample, like we have here, is shredded, and we're going to run that in a glass petri dish. So it just goes into the petri dish adapter. Samples like powders, so if you wanted to analyze a WPC powder, a milk powder, etc., you would measure that in a quartz cup like we have here. So for this cheese sample, I'm going to put it down. I'm going to select the cheese type that I want to run. Here, I've got a message telling me that my reference has expired, so the background has expired. There are references or backgrounds for each channel, and it is set to run those as needed. So I'm just going to click Measure Sample, and I'm going to name it Cheddar for cheddar cheese. And I'm going to click Measure. At this point, it's automatically going to collect a background. So whether that was a liquid sample or a solid sample, if it senses that it needs a new reference or background, it will do that automatically. So we don't need to worry about pulling the sample out. When we collect a reference, we don't need to pull out the flow cell. It will just automatically move the sample out of the way and collect that background. The backgrounds are collected in air. We don't use any type of zeroing solution or anything like that. We're just trying to get a snapshot of the air, the environment inside the spectrometer. So now it's finished its background. It's going to ask me to prompt it to run the sample. So I'm going to click Continue. So now we can hear it moving channels, and the rotator is moving around, and it's going to start scanning the outside perimeter of that sample so we can see all of it. And it's really important when you have a less homogeneous product to have a larger sample cup. So there's different sampling sizes you can get. The more homogeneous your sample, the less product you can get away with. Especially for samples like cheese, we want to have enough sample to see. And then when that analysis is done, like now, you're going to get your result. This is set up for just single analysis. Again, if you wanted to do duplicate analysis on the solids, you could do that as well. And that's shown here with our dry matter, fat, protein, as well as some other parameters for the cheese samples. So maintenance on these is pretty simple. On the LSM, there's some main items that you're going to need to maintain. So the tubing, certainly I would recommend replacing that at least annually. The peristaltic tubing specifically, it's probably going to need to be done more like on the order of every 6 months. But that really depends on the amount of high solid samples that you're running. So the higher solids, higher viscosity samples, those are going to wear out that peristaltic tubing more frequently, and you'll need to replace it more often. But I'd say plan on replacing it roughly every 6 months. The tubing every year. Again, similar to the peristaltic pump tubing, the homogenizer valve just depends on how often you're running a non-homogenized sample. So if you're running vat milk and raw milk frequently, you may need to replace your homogenizer every 6 months or sooner if those are getting a lot of wear. If they're not getting a lot of wear and you're running mostly, raw whey or WPC, liquid WPC, you may not need to replace that homogenizer valve as much. There's some other things with the rotary valve and the actual motors in here that they're going to need some PM, some preventative maintenance at some point, but it's not going to be a regular maintenance item that needs to be changed prior to a year's worth of use. On the spectrometer itself, the maintenance items, there are two main maintenance items. One is going to be your desiccant pack. The desiccant is a molecular sieve. It comes with a spare, and you can regenerate that in a drying oven, or you can just buy a large bottle of 4 angstrom molecular sieve. It needs to be replaced as needed, so probably no more than every month, probably no more than or less than every quarter. It has a dryness indicator on that, so you can just watch that periodically, say weekly, check your dryness level, and as needed, replace your molecular sieve or exchange it, dry it, etc. The other item on the spectrometer that's going to need to be maintained is the light source. So it has a light source that should last 2 years, and it comes with a spare. So when you buy a spectrometer, really you should expect to have 2 years worth of light sources that come with it. And when you do need to change out a light source and you want to do that yourself, it is user serviceable. Side panel comes off, 2 screws, old light source comes out, new light source goes in. So they're very simple to exchange if you want to do that yourself. Certainly for the dairy systems with a liquid module, we do recommend getting PMs on those, just because they're liquid pumping systems. They're going to wear down over time. But a lot of this stuff you can maintain by yourself. That, in a nutshell, is kind of the basics of running the spectrometer and the maintenance of it. It's very simple, very robust. It's designed to run any type of product within a dairy system. So anything from any of your raw materials, whether that be just raw milk or milk powders, to the outgoing products, whether that's your WPC powders, your cheeses, your yogurts, all those types of samples, anything in between can be run on this single system. So appreciate you watching, and please let us know if there's any questions.